If you are building a distributed system in .NET and you want to implement loosely coupled asynchronous communication between your components, you're going to need a messaging service. And Amazon SQS is a scalable and highly reliable option that we're going to explore in this video. SQS is actually short for Simple Queue Service, and it's one of the core services offered by AWS, who is also the sponsor of today's video. Now, before we dive into how to use SQS in your .NET applications, let's first understand what SQS is and why you might need it. So what is Amazon SQS? It's a fully managed message queuing service that you can seamlessly integrate into your applications. It's very scalable and can handle extremely high throughput if you have requirements for sending a large number of messages. It's also highly available, and your message queues are distributed across multiple servers in AWS. And last but not least, it's very cost effective. The first 1 million requests that you send every month are completely free, and after that, the cost to send 1 million requests to SQS is just 40 cents. So I think this is an excellent option if you are cost constrained and you're looking for a very good messaging service. Now, at the core of SQS are obviously queues, which are the building block of a messaging service, and SQS offers two distinct types of queues, standard and FIFO queues. Now, we're going to discuss what they are and the differences between them in just a moment. Now, let me explain how you might use an SQSQ inside of your application and some core concepts that you should understand. So let's say we have two applications, and we want to implement communication between them in an asynchronous fashion. So we can create an SQSQ that we can use to send messages between these two applications. Let's say our first application sends a couple of messages, and they're going to be persisted inside of the queue until the other application consumes them. Now, what's interesting about SQS is that it doesn't use a publish-subscribe approach. Instead, it uses polling on the consumer end to figure out if there are any messages to the queue that they should consume. So our second application starts polling our SQS queue, and let's say it picks up the first 3 messages that we sent. What's going to happen is SQS is going to start a so-called visibility timeout, and during this period, the 3 messages that were polled by our second application are going to be hidden from any other concurrent consumer until the second application either consumes these messages successfully and deletes them from the queue, or it fails to consume them, in which case they're going to be returned back to the queue and other applications can then consume them. So let's say our second application successfully handles these messages and it deletes them from the queue. So we're left with 2 more messages. Now, let's say that the second to last message wasn't successfully consumed, is going to be returned to the queue, and another application or the same application might consume this message again. So this is important to keep in mind. SQS offers at least once messaging guarantees, which means you could see duplicates inside your application. So your message consumers need to take this into account and implement idempotency. So this was the high-level rundown of how SQS works. Now let's actually see how we can create an SQSQ. From the AWS portal, we're going to look for the Simple Queue service. If you've recently used it, it's going to probably show up here. Otherwise, you can just type in SQS into the search box and you're going to find the Simple Queue service. Now, another service that I'm going to briefly mention is SNS, which is the Simple Notification service, and it's very often used together with SQS because it offers publish-subscribe support using topics. Now, back to SQS. Let's go to the SQS service and we're going to create our first queue. So I'm going to click on Create Queue, and right out of the box, we get to choose which type of queue we want to use. We have 2 options, a standard queue or a FIFO queue. Now I'm going to briefly explain the differences between them. A standard queue offers at least once delivery semantics, and it offers best effort ordering. Now, the reason for this is that SQS is a distributed service, which means there are multiple copies of your queue, and when you send a message to SQS, one of those copies is going to receive the request and store the copy locally. Now, the message copy is also going to be distributed to other SQS instances, and when your consumers poll for messages, there's no guarantee that you're going to get the messages in a specific order, and just because the messages are distributed, and you may see some randomness. So if you need to process messages in a specific order, then you're going to choose FIFO queues. FIFO is short for first in, first out, which means messages are processed in the order that they are received, and FIFO-queues also offer exactly once processing semantics. Now, there are a couple of ways how FIFO-queues achieve this. FIFO-queues use a deduplication mechanism, which are going to prevent you to publish the same message to the queue twice, and on the consumer side, you can also use the deduplication identifier to figure out if you've seen this message more than once. Another thing to keep in mind is the throughput that are offered by these two queue types. Standard queues can, at least in theory, scale almost infinitely, so you can send a large number of messages to them, while FIFO queues have some constraints precisely because of the message ordering semantics. Now let's actually create our queue. So because SQS is shared between all of your applications, you should consider adding some sort of prefix to help you identify queues that belong to a specific application. So I'm going to assign a prefix, let's say AWS messaging. You could also include your environment such as development or production. And lastly, you can assign a queue name. I'm going to use a very generic one called messages. The next thing you can configure is the visibility timeout, which is 30 seconds by default. You can also introduce a delay, or when messages are made available to consumers, up to a 15-minute delay. Then you can configure for how long messages should remain in the queue until they are deleted. By default, this is going to be 4 days, and then the maximum message size that SQS accepts is 256 kilobytes. If you need to send larger messages for some reason, then you can do this by uploading the message content into S3 and giving the pointer to the message content to your SQS message. I'm going to leave everything with the default options as well as encryption. I won't change the access policy. I'm going to use the default one, but you're welcome to explore this further if you want to customize it. Now, one more option I want to mention is dead letter queues, which allow you to send undeliverable messages to a dead letter queue. This is going to be a separate queue from our messages queue, and if I click enabled, I get to choose which queue I want to use. I currently don't have one. I will first need to create it, and in that case, I can configure what is the maximum number of times that we can receive a specific message. Let's say we receive it twice, and after that, we can suspect that there is probably an issue with handling this message, and we can move it into a dead letter queue. Now, I'm going to explore this as part of a separate video, so for now, let's create our first queue. You can see that our queue is now successfully created, and now I can go ahead and send some messages. So let's actually send a test message. Just to confirm that this works, I can click send message, and if I go to messages and I click poll for messages, we're going to see the one message that we have below. So now we can take a look at the contents of the message, the attributes, if we include any, and the details that are automatically assigned by SQS. So let's say I don't want to keep this message here, I'm going to delete it, and now we're back with an empty queue. Because polling is a continuous operation, you can also go ahead and stop it. Now let's jump into our application and let me show you how you can integrate SQS with your code. I'm going to start from an empty .NET 9 web API, and I want to install two NuGet packages. These are going to be the AWS SDKs, and the main one we want to use is the AWS SDK for SQS. So let's go ahead and install the latest version. Now I'm also going to look for AWS SDK extensions, and I want to install extensions netcore setup, which is going to make it easier to work with AWS services. So back to our program file, and we have to configure a couple of application services. So I'm going to say builder services at default AWS options, and I want to pull this value from my configuration. So I'm going to say builder configuration get AWS options. So this is going to pick up any configuration that I have in my application settings. It's also going to examine my environment variables, and if you're running this locally, it's also going to look at your credentials file, which should contain your credentials for authenticating with AWS. Now we also want to add an AWS service, and it's going to be the iAmazon SQS service, which is going to allow you to send messages to SQS. So what do we need next? Well, let's go ahead and define a model that's going to represent the messages that we will be sending to SQS, and I just want to create a wrapper class, which I'm going to call the message wrapper. So inside of this wrapper, I want to have a property called content. This is going to be a JSON string if I'm sending in an object, and we can also include an optional timestamp for when this occurred, and let's say I default this property to the current UTC time. So now that we have our wrapper, we also need some sort of message that we want to send. If you don't want to reinvent the wheel, you could explore the Cloud Events standard, which gives you a consistent format that you can use for sending your messages, where one part of the envelope is the actual message content serialized to either JSON, XML, or some other format. In this example, I'm just going to be sending some simple messages, so let's keep it like this. Then I'm going to define a minimal API endpoint for sending my message. Let's call it messages. The request delegate is going to be async. I'm going to be passing in some text that I want to include as part of this message. And of course, I'm going to inject the SQS client so that I can interact with this service. So what do I want to do inside of this endpoint? Well, as with many AWS SDKs, you begin by creating a request object. And in this example, we want to send a send message request. This accepts two arguments. One is the queue URL where we are going to send our message, and the second is the actual message body. So if you recall, the message body is going to be our message wrapper type, and here we just want to include the content, and I can omit the timestamp as is going to be automatically set. So this takes care of the message body argument, and I can pass it here, but remember that we should serialize this, so I can say JSON serializer, serialize, and pass in my argument. Now, what about the queue URL? Well, we have to get this value manually by saying await SQS client get queue URL async, and we have to pass in the queue name of the queue that we want to use. Now, this actually returns our response object, which contains the queue URL value, and then this is the value that we can use inside of the send message request. Finally, I can say SQS client send message async. Of course, there's an API for sending a batch of messages, which allows you to send multiple messages at once. Regardless, you're going to pass in the request object, and this is going to return our response. Now, you can examine this response to see if this was successful or not. Let's assume it's going to succeed because there's a very high likelihood it will. And I'm just going to return the response message ID as an object. So I'm going to say new and create an anonymous object and return the response message ID. So let's go ahead and start the application and test this out. I'm going to send a post request with an example message to my API endpoint, and I'm going to land on the breakpoint inside and retrieve the queue URL. So you can see that this contains my SQSQ address, which also includes the region for my SQSQ and also the queue name. So then we have our message body containing our text and a timestamp. We create a request and we send it using the SQS client, and we get back a 200 OK response. So I'm going to remove this breakpoint and press continue, and let's also send this a couple of more times so that we produce some messages in the queue. And then I'm going to jump into the AWS portal. If I go into my queue and then send and receive messages, I can start polling for messages, and you can see that this is going to retrieve all of the messages that we've sent from our application. If I send another message, it's also going to show up here. So I'm going to stop polling now, and note that these messages will remain in the queue until I've deleted them. So just polling them doesn't actually remove the messages from the queue. So let's go to our application and see how we can start consuming messages. Because SQS uses polling for consuming messages, we're going to need some sort of background service that's going to do this polling for us. So I'll create a new class, and I'm going to call it the SQS consumer service. And what I want to do here is implement my background service, which is natively available in .NET. Then I can register this as a hosted service at startup. So let's specify the SQS consumer service. And when my application starts, my background job is going to kick in and will begin consuming SQS messages. I'm going to need a couple of dependencies. I need the SQS client and a logger so that we can write some things to the console. Then I'm going to assign my queue name as a constant, and I can go ahead and resolve the queue URL by saying SQS client get queue URL async and using the queue URL property. Then what I want to do is create a while loop, and here I want this to execute while the cancellation is not requested. Then we want to initialize a new request, and this is going to be the opposite of what we just did. So this is a receive message request where we can assign a couple of properties. First, we have to set the queue URL. Then you can also configure what is the maximum number of messages that you want to receive from SQS. Let's say we want to get back up to 10 messages. You can also set a custom visibility timeout if you don't want to use the default one. Let's say we set it to 20 seconds. If you omit this value, it's going to use the value that was configured on the queue, which in our example is 30 seconds. Then you can choose the wait time for this request. And this is an important distinction if you want to use long polling or short polling. If you specify a value here, you're going to use long polling, which means this request is going to be open for up to 20 seconds, and in this time period you can wait for any messages to become available. This is more efficient than constantly polling the SQS service and is the recommended approach. If you are using any custom attributes, you can also specify them in your receive request to tell AWS that you want to receive these values inside of your messages. So now that we have this request, we can go ahead and get the response by saying SQS client receive message async and pass in the request. Let's also pass in the cancellation token. And if we don't get back a successful status code or the messages are null, and this is the default value starting from version 4 of the SDK, then I'm just going to say continue and move on to the next iteration. Otherwise, I'm going to try to process the messages. And in our example, we just have the message wrapper, which I'm going to deserialize from the message body, and then we're going to log the contents of this message. And then this is a very important step. If you want to avoid duplicates, you have to delete this message from SQS. You can do this by calling delete message async, passing in the queue URL, and also passing in the received handle, which is available on the message that you just received. It's important that you use this value because it's going to change between multiple consumes of the same message. If we run into an exception, I'm also going to log this, and now I can go ahead and start my application, and I'm going to place a breakpoint here, and we're going to immediately hit this breakpoint. Now let's create our request, send it, and you can notice that we immediately get a response. The status code is okay, which means we have some messages, but recall that we had something like 10 messages in the queue, and in this example we only get 3. So what's interesting here is that even though I specified a maximum number of 10 messages, I didn't actually get 10 messages when I polled SQS. Instead, I got a smaller batch, which could be quickly returned, and then I can process these messages. So I can go ahead and process the message content, deserialize it into my message wrapper object, and then delete this message from the queue, after which it's going to be no longer available. So I'm going to hit continue. And then the next time we send a request, we're going to get just one message, and this can continue until we've processed all of the messages. So I'm going to place a breakpoint here. In the background, I press continue, and note that we've processed all of the messages that we've sent in the meantime. Now notice that we still didn't hit our breakpoint. This is because my long polling is still in effect, and I'm waiting for up to 20 seconds for my request to complete. Now when this expires, the request is going to complete, and we should hit this breakpoint. Now notice that in this case, the HTTP status code is still okay. However, the response messages object is null. This means that we got no messages from the SQSQ, and we can proceed to our next polling request. Now I'm going to stop the application here. Now where you want to take this next is add some more resilience to your message consumption. In a realistic scenario, we aren't just going to be logging this to the console. We actually want to do something with the message content, like invoking some custom handler, and then it becomes important to differentiate between different message types. Now this is going to lead to reinventing a messaging framework around SQS, which isn't something I want to do. Instead, I'm going to show you something exciting that AWS recently released, but that's going to be a topic for a future video. If you enjoyed this video, make sure to hit the like button right below, and also take a look at the pinned comment if you want to get some free AWS credits. Take a look at my courses if you want to improve your software architecture skills, and until next time, stay awesome.